We now introduce the factorial notation. For each positive integer n factorial is defined to be n times n minus 1 times, and continue this pattern, which is decrease the value by 1 until you multiply down to 3 to 1, and when you multiply to 1, then you stop. We also defined 0 factorial to be 1. Okay, so just a few examples, let's look at a few examples right here. So 9 factorial means 9 times 8 times 7 times 6 times 5 times 4 times 2 times 3 times 2 times 1. That's how 9 factorial is defined. Do you see that 9 factorial, if you look at that? So this actually is 8 factorial, right? This is 8 factorial. So 9 factorial is actually the same as 9 times the 8 factorial. Of course, if you can also look at it that way. Do you see that this is 7 factorial? 7 times 6 times 5 times 4 times 3 times 2 times 1, this is 7 factorial. So, or you can look at it like this is actually 6 factorial. 6 factorial, okay? Now, and then divided by 6 factorial, 6 factorial. So here's the reason I did not expand the 6 factorial, because I want you to see that actually 9 factorial can be written as 9 times 8 times 7 times 6 factorial. So a little redundant for me to expand this, but anyway, and then I can actually cancel that, right? So they cancel to 1. So therefore this is equal to 9 times 8 times 7, which is 504. Okay. Now go back to this, is that true or false? M factorial is n times n minus 1 factorial. This is actually true, right? That's like 9 factorial is equal to 9 times 8 factorial. And then 8 factorial can be written as 8 times 7 factorial, and so on and so forth. You can just expand it, and then you will see. Okay. Because what is n minus 1 factorial? It is n minus 1 times n minus 2. Just keep subtracting until you're down to 3 times 2 times 1. So this guy is basically the n factorial. So this is actually true. This is definitely true. All right, go back to the problem. Let's compute another one. So to find the 7 factorial over 5 factorial and 2 factorial, we have, okay, 7 factorial is 7 times 6 times. So I really do not bother to expand the 5 factorial, like 5 times 4 times 3 times 2 times 1. I do not really need to expand that, because I see another 5 factorial there. I want to save me a little time writing, and then because I know it will cancel, so 2 factorial. Now 5 factorial and 5 factorial cancel, so we have 7 times 6, which is 42. 2 factorial means 2 times 1, right, which is 2. So divided by 2, this is 21. Okay, now let's look at then another one here. I certainly would not compute 11 factorial, which is a huge number. If you multiply 11 times 10 down to 1, it's a huge number. 12 factorial is even huger, okay, more huge, larger. So here I look at, by looking at that, the last smallest number is 10 factorial. So how about we write that in terms of 10 factorial? So 11 factorial is 11 times 10 factorial, plus 12 factorial is 12 times 11 times 10 factorial, divided by, the bottom is 11 times 10 factorial, and plus 10 factorial. And let's factor out the 10 factorial, or you can think of dividing both top and bottom by 10 factorial. So we are left with 11 plus 12 times 11, divided by 10 factorial, and then this is 11 plus 1. And now this 10 factorial can cancel, right? And therefore we have 11 plus 132 divided by 12, which is 143 divided by 12. Okay, And I think that's it. Actually, this is going to be 11. This is 12. I'm sorry. This is 12. So I think we cannot simplify it any further. All right. So next one, n plus 2 factorial divided by n minus 1 factorial. So how do I handle that? Even though we do not know n, we certainly know n plus 2 factorial can be written as n plus 2 times n plus 1. Just keep subtracting 1, decrease by 1. And then here this is going to be n. And here this will be n minus 1 factorial, right? Okay, divided by n minus 1 factorial. So and then let's cancel that. And then this is equal to n plus 2 times n plus 1 times n. Okay, so this is what it is. So you do want to work with something like that, because real soon when we do proof, we need to be familiar with those stuff.